Hello everyone. In this video, I am going to discuss how to use a single loop to work on the multiple data sets instead of only one data set. Suppose I want to work on a 100 data sets simultaneously and find the mean, variance, and other summary statistics for each of the data sets for specific variables. And then we want to find 100 mean for the 100 data, 100 minimum for the 100 data. So that means when we will run the for loop, how can we work with the multiple data sets, for example, 100 data sets to find summary statistics. And in addition to that, we want to learn how to make long data to wide data and wide data to long data. So data is in long format. I want to make in a wide format. And after that, I want to discuss like how to merge the two data sets by ID variable and how to append one data beneath the other data, below the other data. These are the things we are going to learn in this video. So I have started recording the class. I have shared the screen. So let me directly go to the Python. So as I mentioned in my week 4 lecture, these are the packages that we need to import. And then this is like how to get the working directory. And this is how to set up the current working directory. This is the way how to import the data. Either you can run like line 20 or 22. Line 22 directly import the data without declaring working directory. So after that, I have selected some variable that are not I have excluded some variable that are not important, which is mentioned in this document. Let me open the week 5 document. So, by ignoring these variable. This variable I do not want to have. So that is why I put here exclude. I want to ignore that variable and I want to keep the variable. And finally, I want to make a copy of it. This is my variables. After doing this, I want to check how many rows, how many columns in the D2 datasets. And then from the D2 datasets, if there is any row that has a missing value, I want to delete that row by running the line number 37. So now if you take a look at the np.shape for the D3 data, you will see there is a significant reductions of the data. Let me see. This is called np.shape. And then I want to put here D3. That is the way I are getting 17,025 rows. 17,025 rows I got. After that, 17,025 rows I got. Now I want to create a, so take a look at the data D3.head. So in these data, if you take a look at the age values, this is the values for the age variable, but I want to round them to the 1 decimal place. So in that way, if I run the line number 41, which rounded the current age variable to 1 decimal place, and the name of the new variable is new age. And if I run it, we got this one. And then if we write it d3.head, we got this one, this new age variable, 9.4. Previously, it was 9.35. So I rounded the age variable to 1 decimal place. After doing that, I want to subset the data, D3 data, by taking age value greater than 9 and less than 19. So this is what I'm doing in line number 45. New age variable will have age values greater than 9 and less equal to 19. So if you run these things, then we have a new data. That data is D4. And now this default data is my new data, which is a final data for my analysis. So suppose these data I want to give someone working under my supervisions, and how can I give that? So this is the line number 49. If I write D4 to dot 2 underscore CSB and name it as a D5 clean data. This is a completely new name that I have given. Okay. If you want to put some other name, you can put there. And then D4 is the new data that I want to export as a CSV format with a new name D5 underscore clean data like this. So data will be exported in the current working directory. If I run this, so data will be in the current working directory. But if you are not sure where the data is, if you just copy these things, and put it in the search bar, and you will see data will appear. So data will appear where? This is the location which was your current working directory. Data will be stored in your current working directory. So this is the D5 underscore clean underscore data, which I have created as a new name, but this is actually the data that is a default data. So default data I have created and saved somewhere in my computer. Okay. So question number 8 is telling you how to export a clean data to somewhere in your computer, and where it should be saved. It should be saved in your working directory. Okay. After that, I want to subset the uh, default data by age variable. If I run the line number 53, so default data is subsetted by group by, or subsetted group by new age variable. Now take a look at that. Now we have a one data for age 9.1. Take a look at that. This is a one data for age. In this case, new age variable, if you take a look, new age variable has value 9.1. Now, if I take a look at the second data, not second data, I think it is 11 data that has a age 11. Now, if I want to take a look at the second data, if I put here 9.2, and then hit enter, then 9.2. So this is the way I will get all the data. So this is the data corresponding to age 19. So line number 16 will give you the data corresponding to age 19. Okay. So renaming split data as D5. Okay. So now in the D5 data, how many data are in there? Now take a look at this. These data, these D5 has a number of data. Instead of one data, D5 has a 100 data. First data for the age 9.1. Second data is for the age 9.2. Third data is for age 9.3. And then 10 data is for the age 11. And 11 data is for the age 10.1. In that way, 100 data is for the age 19. So D5 holding 100 data sets. So D5 is now known as a list. A list is a placeholder of 100 data set. Okay. So D5 is a list of 100 data. So how can you know that it has a 100 data? If your length of D5 is giving you 100, so that means D5 has a 100 data. After that, if you want to write like this, print D5 dot size, so that means 9.1 has a 60 rows, 9.2 has a 90 rows, 9.3. Now, let me, data corresponding to age 9.1 has a 60 rows. Data corresponding to age 9.2 has 90 rows. Data corresponding to age 9.5 has 91 rows. Data corresponding to age 18.9 has 147 rows. Data corresponding to age 19 has a 119 rows. So the column number for each data is the same. That is why column data is not shown in here. Okay. Are in there 17,000 something, 16,055 data points are in there. Okay. Now I want to use the single loop or for loop to find a mean, to find a mean of SBP, mean of DBP, mean of height, mean of weight, mean of BMI for each of these data. And in order to do that, we have to run the loop. How can I do that? So DS rows for underscore rows in D5. Take a look at that. If I run this, so rows for underscore rows in the D5. So D5 is a list. D5 is a list that is holding 100 data sets. Okay. So, and then import statistics and SS and data list. So I am putting a blank data list, and then I am putting for I in range length of DS. So length of DS means this here, length of DS equal to 100. So I in range length of DS. So length of DS equal to 100. So that means I take value 1 to 100 for when I equal to 1, first data corresponding to age 9.1. When I equal to 2, second data corresponding to age 9.2. When I equal to 100, the data is corresponding to age 19. Okay. So this is the for loop. And for each of these 100 data, it is running and finally computing this mean. After computing this mean, we put that in a beautiful concatenate format and finally get the output. Take a look at that. If I run this, see, this is the output we got. So mean SBP, mean DPP, mean height, mean weight, mean BMI for the age 9.1, this is the mean. So now 9.1 corresponding to age 9.1, we had a data. On that data, I find the mean of SBP. Corresponding to age 9.2, we had a data. From that data, we got the mean SBP. In this way, the line number that you are seeing 75 until 89, these few lines of code. So how many? 75 to 89, right? 75 to 84 is 10, and then 11, 12, 13, 14, 15. These 15 lines of code. Okay. These 15 lines of code. These 15 lines of code, you are working on a 100 data sets. These 15 lines of code that you are using from line number 75 up until line number 89, you are working with the 100 data sets and you are finding 100 mean for SBP value for 100 ages, 100 mean for the DBP value for the 100 ages. That means 100 data. For example, USA has 50 states, and then you want to work with the all 50 states together. So this is the code that you can use. You do not need to do work with the first Alaska, then Alabama, then Arizona, and finally Wyoming, something like this. You do not need to work like that way. What you need to do, all the states data is in there. You just write a single loop or for loop, and I equal to 1, first state, I equal to 2, second state, I equal to 50, 58 states, and then find average age of death, average income, average household, average home prices for each states. And that things could be done just if you become a master of these 14 or 15 lines of code. Okay. Now the question is, how can we do the same thing? How can we do the same thing without using for loop? So if you do the same thing, D4 group by new age by mean, then it will give you the same thing. So new age, and this is the mean for the raise variable. This is the mean for the income. This is the mean for the age, like that way. Okay. So Python has this opportunity to write these things. Many other software does not have this. For example, I do not know whether these things could be done using R in this format. There may have, but at least, well, there is a aggregate thing. We can use aggregate thing. Yeah, we can use aggregate functions to compute same thing. But that is the for loop function you can use. Sometimes this function may not work in a situations, but for loop that I showed from line 75 to 89 will work. Okay. So alternative approach is this one. You can also find this one, group by finding mean, median, and their name. That. So different approach for overall measure instead of the split data. So for the split data, for instead of split data, for the entire data, if I want to find, that could be obtained by using this, by writing a simple function that you learned from the first class. Okay. So this is for by writing a function overall mean for all the variables. If you specify, then you will get these things. Question number 16 is giving you, so data is in a long format. Let me explain you what is long format. So D1.head is the data. In this data, if you take ID, race, all of these variable, right? So this is called the long format data. And instead of this data, I want to make it as a wide format. Okay. How can I do that? ID, visit, and SBP variable I want to use. And then I want to turn only with these three variable, these data to a wide format data. So that means now it is coming visit is a variable. Now visit is a variable, and visit has a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, right? But now instead of a column, it will be a row. This will be visit 1, visit 2, visit 3, visit 4, visit 5 will be written in the column, and corresponding to visit SBP value will be given corresponding to the ID. That is called the wide format data. Currently, the visit is a column format and only one visit variable, and under that the number 1 to up to 10. Okay, but it will in white format, visit will be in the row, and then each the visit row has a visit 1, visit 2, visit 3 up to visit 10. Corresponding to visit this 10 visit, under that there will be SBP value. So you see, let me run these things. So take a look at that. Now take a look at that. Visit 0. This is visit 0. Okay. And then visit 10. Okay. Now visit 0 to visit 10. So this is the one person's ID, 50,000. This is his ID. This is all of his informations in here. Okay. Then it will go his visit 2, then it will go to his visit 3, then it will go to his visit 4, visit 10. Similarly, now previously ID was appearing. Let me show you again. Are you seeing ID? Same person. 50,000, 50,000, 50,000, 50,000. Now this 50,000 appearing only one time, and all of these, his visit is appearing in this format. Okay. So this is the way. This is the way it could be done. This is called the wide format data. Long format data, variable is appearing only one time, and then number of visit is coming according in each column. But now it has been transferred to the rows. Each person has only one ID. All the values has been put in the column instead of multiple same ID. Now it has only one ID. Okay, this is called the wide format. So similarly, wide format data I have, how can I transfer it to the long format? So that is what mentioned in the line 125 to 128. This is called the long format data. So now you might ask me question, hey, professor, the data is in the long format most of the time. Why should we need to transfer our data from long format to wide format? Well, if this is your question, the answer is the wide format data person is appearing only one time. And then like if I want to compare like all the persons between first visit and 10 visit. That could be done only if data is in the wide format. Okay. All the persons difference between first visit and 7 visit. That could be done if data could be transferred to the wide format, otherwise not. In bioinformatics and genomics, statistical genomics, where there is a thousands and millions of genomes data is in there. In that case, wide format data is applicable for running pairwise t-tests to see the statistical significance. And then there is a lot of other things known as the false discovery rate, like the these are the things could be done only if data is in the wide format. Okay. And then now I have a data known as the D1 N1 data that I have selected with the 4 variable ID, age, SBP, and DBP variable. And then another data I have selected with ID, height, and weight variable. Okay. Now, how can I merge these two data? These two data could be merged by using ID variable by running the line number 142. Okay, so this is what called the side-by-side merging. How can I merge the data by ID variable? Okay, and then there is another merging which is called the one below the other, which is known as the appending. Suppose I have this amount data which has 1,000 rows or 10,000, 1,000 rows that I have taken, and then another data N2 that I have taken from D1 data. So I want to merge one beneath the other. So this is the way two data could be merged. This is the way two data could be merged. Okay. This is the way two data could be merged. Okay. So in this 23 problems, we have learned how to work with the multiple data sets, how to transfer a long format data to wide format data, how to transfer wide format data to long format data, how to merge two data sets by ID variable, how to append one data with another data when the variables name are the same. So that's it for today. So our 6 weeks materials will be on the visualizations. So I will upload the 6 weeks material in next week. Thank you very much. Bye.